All right, good day, guys. Hope you're doing all right. Hope you had some good times. But let's get back into it. So, as I said, we're going to be starting lesson 8 today. And lesson 8 is going to be estimating square roots using benchmarks. And so, what does that mean? We're going to find out. I just got to get the tools going, and then we're going to get started. Behind the scenes now, getting a little more in depth into our school year. Okay, awesome. So I think we'll stick with the blue. It stood out a little more. I kind of like that. Hopefully you guys did. As I said, if you have any comments or feedback, please let me know always, right? Okay, estimating square roots. So this is when we have numbers and maybe we don't have exact perfect squares or perfect square roots. And so we're going to use the numbers that we do know in order to determine the numbers that we don't know. And then we're going to do a little estimating. Thing I want to make sure that we understand fully and clearly is estimating isn't just guesstimating, okay? So guesstimating is when you just guess a number, you don't have a whole lot of evidence or anything to back up your claim. Estimating is mathematical, where we use all the information we have to get as precise a number as we can, okay? And so we're going to look at how to do that today in a pretty simple manner, I think. Okay, anyway, so many fractions and decimals are not perfect squares, and this is true, right? We have for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 here, and those are nice, neat numbers, but as we've learned with decimals, there's a lot of numbers in between 1 and 2 even, right? Technically an infinite number of decimals you could do. So, and they cannot be written as a product of two equal fractions. A fraction or decimal that is not perfect, a perfect square is called a non-perfect square. Mind blown, I know. You can estimate square roots that are not perfect squares using benchmarks, okay, of perfect squares. So these are perfect squares, and they align with the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, okay? I know, seems basic, we're counting to 13, but this is going to be important to know. All right, so let's keep it moving here. Kind of get back to the grade 9 level of things. Okay, so if we want to estimate a square root, we need to kind of know what numbers are on either side of it. So what I always start to do is I write my number. I want a number that is greater than, and a number that is less than. Again, for our perfect, like for our squares. So here we have 22. Well, the next nearest square is going to be 25. So we want 25. Okay. Over on this end, less than 22. The next nearest perfect square is going to be 16. Okay. 16. Square root of 16 is going to be 4. Okay. And the square root of 25 is 5. So we know our number is going to be somewhere between 4 and 5, okay? And this number is not quite in the middle of 16 and 25, so I'd probably say maybe 4.7, could be 4.6, 4.8. You know, if you did 4.1, I'd probably say maybe look a little bit closer because it's not like 17 or maybe even 18. But anything 4.5 to 4.8 would probably be no problem, okay? And that would be all. You have justified your answer by showing that the square root of 16 is 4, the square root of 25 is 5, and your number is somewhere in between. That's all, okay? If you want to be extra clear, you could rewrite it underneath, circle it, underline it. Doesn't matter. If you did this, though, I would mark this 100% correct. All right, B. So here we have the square root of 13.5, okay? So same thing there, right? We're going to rewrite 13.5, a number that's bigger and a number that's smaller, okay? So here, we know the next nearest is 9, and 1 up is going to be 16, okay? Square root of 9 is 3, square root of 16 is 4, and so we know our number. Sorry, guys. Whoa. Here, maybe my hand's in the way. There we go. Is going to be somewhere between these two. Again, it's a little closer to 16 than it is to 9, so I'd probably do 3.6, 7, in that range, no problem. Okay. Ta-da! That's the first step. So now we're going to add in fraction. All right, guys, so now what we're going to do is looking at how to do fractions, right? Because we always like to complicate things with fractions. So here you can estimate a square root of a fraction by finding the closest perfect square to the numerator and denominator. Okay, so we're going to start the same way, and then we're just going to change one little bit because we do need to find some common ground between our fractions. So here we go, 23 over 80. We just rewrite it. We need a fraction that's smaller and a fraction that's larger. So smaller, 16 over 64, which is the same as 4 over 8. Okay, and then we're going to go on the flip side, and we're going to go the square root of 25 over 81, right, which gives us 5 over 9. Okay, and then we're just going to change it up a little bit because we're actually going to keep this in between for now. And then what we want to do is find a common denominator between 8 and 9, okay? So here what we can do, if we take this, simplify it, right, as 1/2, 4 over 8, same thing as 1/2, okay, and then we can take that, and 2 times 9 is going to be 18, so over 18, right, and 1 times 9 is 9, so 9 over 18, right? And then here we go 5 over 9 times 2. We end up with over 18 and 10. Okay, so we now know our number somewhere between 9 and 10. Probably pretty close. Okay, so then what we're going to do here, right? We're still not quite where we want to be. I'm going to skip to the next page and just rewrite things a little bit. It complicates it, but that's what we can do. So 9 over 18. 18. Less than the square root of 23 over 80. And we end up with 10 over 18. Okay, so to simplify this, right, with the fraction, we can't go anywhere between 9 and 10. So what we're going to do is we're going to multiply these by 2. We're just going to double up, and it gives a little bit more wiggle room. Okay, so 18 times 2 is 36. Okay, let's put times 2 times 2. And then same thing over here. Okay, so we end up with 18 over 36, and then our number's going to be somewhere in between, and then here we go 20 over 36. Okay, now we've doubled everything up. We give a little bit more wiggle room in the middle, so we can see here that our square root is going to be in between 19, right, and out of 36, and so it has to be right in between those two numbers. Okay, so let's go back up. We're going to look at our last problem and hopefully solve it the same way. Okay, so here we go, square root of 8 over 17, okay, and that's somewhere in between 9 as a perfect square and 25, and over here we end up with 4 over 16. Okay, so same thing, this here is 2 over 4, and square root of 8 over 17. Then we simplify it a bit further and we end up with the square root, not square root, we got rid of that. We're going to simplify this to 3 over 5. Okay, not quite there, but we're pretty close. So what we can do, common denominator, times 5 over here, and times 4 over here, right? So we end up with 10 over 20, right, and end up with 12 over 20, okay? And so now we can see we're right in between with 11 over 20, and that would be your final answer, okay? Awesome. Guys, great job. Let's keep going. Almost there. Okay, so determine an approximate value of each square root. Okay, let's take care of this, and then we're out of here. So, approximate square root, right, of 14, smaller, square root of 9, larger, square root of 16. Okay, and so here we go with 3. Our number is somewhere between 3 and 4. Pretty close to here, so I'd go maybe 3.8. Ta-da! Okay, and let's finish her off. So square root of 31, larger is 36, smaller, square root of 25, Okay, 5, 6, and our number is somewhere in between these two. I'd say almost halfway, so we can just go 5.5. Yeah, if you're a tenth of a decimal off, like 5.6, 5.4, I'm probably not going to reprimand you or take any marks away. So just to let you know. But as long as we're close, you show your work, you can justify your work, that's what I'm looking for. Okay, anyway, have a great day, guys. We'll see you around.